The objective of this lesson is to apply understanding of statistics to make an informed decision. Let's look at the task. You are a manager at a video game testing center. Your employees play new games to find bugs or errors in the game so that the game designers can fix the errors before games are released to the public. You want to promote your best employee. Using your understanding of statistics, use the chart to determine which employee should be promoted. You will need to explain to each employee why or why not they received the promotion, so it will be important to build a strong argument for both using statistical evidence. Let's look more closely at the chart. There are 2 employees and a list of the number of bugs they each found over a 12-week period. It is difficult to accurately evaluate all of the data when placed in this type of chart. One way we could evaluate the data is to make a line plot or dot plot for each employee. Let's look at Bria first. It will be helpful if we have a dot plot. It appears as if the fewest number of bugs Bria found is 29. The largest amount she found is 73. This makes for a large range on our number line. 73 subtract 29 equals 44. There is a range of 44 bugs for Bria. Now, let's plot our data on the dot plot. Next, let's look at Dorian's data. Dorian's range of data is 56 subtract 31, which equals 25. Looking at both line plots, we can see the spread of data for both employees. Looking at the number of bugs Bria found on a line plot, we can conclude that her data is more spread out. She does not consistently find the same amount of bugs each week. His data is closer together. His ability to find bugs seems to be more consistent. Another way we can compare the number of bugs found by each employee is to find the median or the middle number of each set of numbers. First, each set of data will need to be put in order from the smallest number to the largest number. Let's start with Bria. Count in from each side until we find the 2 middle numbers. The 2 middle numbers are 45 and 49. We need to add them together and then divide by 2 to find the median. The median for Bria is 47. Looking at Dorian's numbers, the 2 middle numbers are both 47, so the median is 47. Now, let's find the measure of center of each employee's bugs. Let's start finding the mean of Bria's bugs. First, add up all of her bugs, and it equals 573. Then divide by the total number of weeks, 12. The mean or average for Bria is 47 and 75 hundredths. Now, let's find Dorian's mean. Add up all of Dorian's numbers, 552, and then divide by the total number of weeks, 12. The mean for Dorian is 46. If we compare the mean of the 2 employees, Bria has a higher average. Now, we need to look at all of our data and decide which employee should be promoted. Bria has a range of 44 and a mean of 47 and 75 hundredths and a median of 47. Dorian had a range of 25, a mean of 46, and a median of 47. Using this data, who should be chosen for the promotion? When we first look at the data, Bria has the most number of bugs found. Bria's numbers are all higher. However, because her spread or range was greater than Dorian's, it can be concluded that she is less consistent than Dorian at finding the bugs. She also only had 1 week with the same number of bugs, which gives her less reliability as a worker. When we first look at Dorian's data, his data stayed pretty consistent. With these statistics, we can conclude that Dorian is actually the employee who should be promoted. Students should be able to argue for and against for each employee, then reasoning using all the measures of center to read the data and conclude who will get the promotion. The objective for this lesson was to apply understanding of statistics to make an informed decision. We met this objective by making a line plot for Bria and Dorian and comparing the data, finding measures of center to include the range, median, and mean.